I'm Claire. Today let's talk about the third video of the Cardano equation. So in this video I'm going to add everything about Cardano equation that I didn't tell you before. So the first point, we know that for example we set a question as x is 3 minus 3x plus 2. So the question is over here. Then we know that we set in this question using u plus v, or as the hope function, right? M plus k over m. And if it's u plus v, so we know we can just think about that u and v, we change their root, right? We change their root. And then, so in the 3-dimension, I talked about it before also. So in this video, we're going to talk about it. Actually, because we know, because in this question, right, now we will find out that u is equal to square root. So in this question, I'll tell you, in this question, we find this question when delta equals 0. And so here's the point. When delta equals 0, okay, then we will find out, because it's cube root, right? And then the inside it is negative q over 2. So that is negative 1, right? In this case, because it's, okay, 2 divided 2, that's negative 1 over here. And then plus square root delta. So I told you this is equal to 0. Of course, you're going to also, about v. Okay, v is equal to square root, cube root, and then negative 1 minus square root delta. Then, of course, this is equal to negative 1, and this is also equal to negative 1, so x equals negative 1 plus negative 1 equals negative 2. Great. So this is the normal method, but actually, we have another setting method. Is that we set x equals to u plus negative v. So that's u minus v. But when we think about, we let u and negative v change their value, change their root, it's u axis and negative v axis, not u and v axis. Then we cannot change because the symbol over here is negative, but the correct thinking method is think about u and negative v, these two axes. Okay, so what do we have? Let's take a look. So in the processing, it's totally same, but the difference is just u and v. So actually, finally, we're going to find out u and v. Actually, we're going to find out negative v, but we're actually, over here, we'll just write it as v. So we have square root, cube root, and then negative 1, negative q over 2, and then plus square root delta. Okay. Then in this case, it is different. Then v, it is equal to cube root, and over here it is positive q over 2, so that is 1, and it's the same symbol over here. But this method, the two symbols are opposite, and these two symbols are the same over here, and then square root delta. So in this case, then u is equal to negative 1, and v is equal to 1. And so this is correct, because in this again, we'll have negative 1 plus negative 1, because it is, think about negative v over here, so that is correct. Okay, so that is also equal to negative 2. So we're going to compare these two methods. Are their answer the same? So, of course, we know these two symbols can change. And these two symbols, they can both change to negative. So let me write out. The first is that x equals u plus v. Okay? And then this is equal to square root, cube root, and negative q over 2. Then plus square root delta. And then plus cube root negative q over 2 minus square root delta. And then or cube root, and then here's the same q over 2, but this is minus square root and plus cube root negative q over 2 plus square root delta. X equals u plus negative v. Okay, in this case, then that's equal to cube root and then negative q over 2 plus delta. And then plus cube root q over 2. Remember the q over 2 and then plus square root delta. And then or cube root and negative q over 2 and then minus square root delta. Sorry, here's supposed to be minus square root. Cube root q over 2 minus square root delta. Okay, so we're gonna compare. So first, compare. Of course, these two guys. Of course, they're the same. I'm gonna think about these two guys. Actually, they're the same because we put in the negative over here. And that's over here is negative q over 2 minus square delta. And over here, this is negative q over 2 and plus square root delta. So these two, actually, they're also the same. Okay, so we can just compare. Because, for example, we can compare this guy with this guy, and this guy with this guy. Okay, we'll compare. If it's this with this, and these two, so not like this. It's supposed to be okay. These two guys, these two parts are the same. So we put the negative symbol over inside. To the inside, it's also same. See, put this in this same. These two parts are the same. And put this negative inside, negative symbol inside. Okay, then these two guys are the same. Okay, so actually now we have done is to compare x equals u plus v and x equals u plus negative v. They're actually the same. So the first method map to the second method. The difference is v. One is v and another one is negative v. So I told you, what have we done? Every step, we actually from the first method to the second method just change v to negative v. Remember the plus bracket? And so we're going to find that the final root of uppercase U and uppercase V is that in this case, we're actually going to find the root of negative V, right? So actually here I should have just supposed to write plus negative bracket negative blah 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 bracket. So in this case we know how to do this. Okay, so this is the first thing. We know that we can use u plus negative v. It's totally the same because I told you we change v to negative v. So in the graph, we think about the negative v axis. So nothing changes. Okay. So the next step is to tell you another method. Okay, so the next thing I'm going to tell you is about another method. So, the first thing we're going to know is about A minus B. You'll feel a bit strange about this. Okay, so first step is to change it to square root A plus square root B times square root A minus square root B. You know what's that, right? Okay. And the next step, you can change it to bracket cube root A and minus cube root B. Doing it at times about the cube root, and then that's bracket. No bracket. Cube root A square, because it's cube root A times cube root A. Okay. Because it's actually this whole thing to times 3 times it, and when we times 2 times of it, and just it's plus cube root AB. Actually, it's cube root A times cube root B. So we're going to put them together. That's okay, and then plus cube root B to 2. Okay. So, next step is about, if we think about A plus B. So that's going to equal to cube root A and plus cube root B. Okay, so then times, and A square, cube root A square, minus cube root AB plus cube root B square. Okay, so over here, now we know over here, we can just solve the question. So the question is x to the 3 plus 9x minus 10. We're going to find out when it's true. Okay, so here's a new method. We can guess. So x to the 3 plus 9x minus 10, and that is equal to x to the 3 minus 1 plus 9x minus 9. So we're going to be having x minus 1 bracket x to the 2 plus x plus 1. Then plus 9 times bracket x minus 1. Great. So, of course, then that's equal to bracket x minus 1 times x to 2 plus x plus 10. Good. Then we will know. We can guess of this function, and x minus 1 times x plus 1 over 2 bracket t2 plus 39 over 4. Great. Okay. So what is this equal to? So, we're going to find equals 0. So this part equals 0, all this part equals 0. But this quadratic equation did not have root. Real number root, of course. So we only can find out that we let x minus 1 equal 0. Then x equals 1. This is one root that we can actually find out. And then we know using the Cardano method, I don't write the, I just read the result and just use these three equal 5 plus 2 square root 13. And then these three is equal to 5 minus 2 square root 13. Great. When we have this, then we know x is going to equal to u plus v. And that's equal to cube root 5 plus 2 square root 13. And plus square root 3, not square root 3, cube root, and then 5 minus 2 times square root 13. Right, when we have this, we're going to find out, oh, so we have a square root thing. So how can we know what's the real number of it? So actually, we can use other tricks to find out a value that we know. For example, actually, answer of this I'll tell you. It is 1. But we can use trick to find out this. So first, we know x is equal to this. Okay, so both are square. So x to these 3, and that's equal to 5 plus 2 square root 13 and plus 5 minus 2 times square root 13. Okay. Then we're gonna plus 3 times cube root 5 plus 2 times square root 13, and then times cube root 5 minus 2 times square root 13. Of course, then we're also going to times cube root 5 plus 2 square root 13, and plus cube root 5 minus 2 square root 13. Great. What is it equal to? Equal to, over here, of course, the 10. 10 plus, now this part turns to 3 times cube root 25 minus 4 times 13. Right. Okay, so this is not 3 to this 3. Okay, so like this. Okay. So, this case, we'll find out that x is equal to, not over here, times x. Okay, so we'll find out this is equal to 10 times 3 times cube root negative 27 times x. Then that's equal to 10 minus 9x. Okay, then x to 3 plus 9x minus 10 equals 0. Then we will have x minus 1. Okay, then x squared plus x plus 10 equals 0. Then we'll have x squared. I don't write it because this part we don't have a root, and so x equals 1. Okay, so that's it. Then we will have that this whole part is equal to 1. Yeah, you get it, right? Okay. So now, over here is the point. Because we actually can think this part as, of course, including the cube root. So, cube root. So inside, we can write it as m plus n square root k. So there's some conditions. And the first condition is n greater than k. And a is going to be equal to, this is what we set as a. And then n equal to n minus k over 3. Great. And a to the 3 plus 3ak equals m. So, what is this equal to? Wait. So, what is this equal to? So, we'll think. If we have a equals this guy, and then, so, a to the 3 times a to the 3 plus k is equal to n. Right? So in this case, including this, if we put it inside, then we will actually have inside the cube root, it turns to bracket a plus square root k bracket to the 3. And so that is equal to a plus square root k. So, over here is that we will have some trick else. So let me see. Okay, so another trick over here is also about this part. So, first we will have this part. So first we know that, so inside, so 5 plus 2 squared 13. So we can just change it to, we can just change it to 5 plus 4 square root 13 over 4. Great. Okay, m over here is equal to 5 and n equal to 4 and k equal to 13 over 4. So this cannot be true because 2 is less than 13, so we cannot use b because n has to be greater than k. So over here in this case, then it satisfies. Okay, so then what is a equal to? A is equal to, okay, then n is equal to 4, right? And so it's square root 4 minus 13 over 4, then whole thing divides 3. Okay, what is this equal to? So this is equal to square root 16 minus 13 divides 3 times 4. And so that is equal to square root 3 over 3 times 4. So it's equal to square root 1 over 4. And then that's equal to 1 over 2. Okay, so what about this guy? We find a, and a to the 3 plus 2ak. So a to the 3, it is 1 over 8. Okay, so it's 1 over 8, then plus 3 times, so this is 1 over 2, right, and times k over here is this guy, okay, and then so we have 3 times 13 over 8. So it is equal to 1 plus 39 over 8. And then that's equal to 40 over 8. And that's equal to 5 equals m. So that's correct. Okay, so I have the next step because we know what's inside over here. And so the whole thing to the 3. So, the cube root to the cube root, and then so we know the whole thing is 1 over 2. 1 over 2. We have this, and then plus square root 13 over 4. Okay. The whole thing to the 3. Okay, so we actually have that. Okay, so 1 over 2 plus square root 13 over 4. Okay, so we have another part, right? And another part, because I'm using what we know over here, because their sum to be 1. Then we know cube root 5 minus 2 square root 13 it should be equal to what? It should be equal to 1 over 2 minus square root 13 over 4. So when they plus together, that's equal to 1. Okay, so here's something I'm gonna add. So because I just lost the, I'm just gonna add another example. And here in this example, it is when delta is less than 0. That's why I have this picture, right? So this question is, let's see. This question is that x to the 3 minus 7x minus 6. I'm gonna let it equal 0. So actually, we can actually change it too. So if you know this problem a lot, you'll find out that you can just change it to x to the 3 plus 1, then minus 7x minus 7. So in this case, you'll have, and that's is equal to x plus 1, and then times x to the 3 minus x minus 6. Great, and you'll have x plus 1 times x plus 2 times x minus 3. And that's equal to 0. So you get the answer is x1 equal negative 1, x2, so this x1, and x2 equals negative 2, and x3 equals 3. So this is the point. So if we have these 3 roots, and another thing, if you use Cardano equation, you'll find out. So first, the point is here. If we use the Cardano equation, because in the last video I talked about it, if we use the Cardano equation, when delta is less than 0, we have a special method to calculate it. So in this case, we calculate it using the special method, because in that special method, it can just use a special method to calculate and find the 3 roots that they are all real number root. It's not like if you just use a normal u plus v and omega u plus omega 2v, in that case, you'll find out that you exist I. So I don't know how to solve it. So maybe you'll just, the I will vanish, but you don't know how to prove it or some kind of, Then we have a special method. Then in that case, if we use the Cardano equation, we will have x1 is equal to 3, and x2 is equal to 2, negative 2, and x3 is equal to negative 1. So in this case, we'll have these 3 roots using Cardano equation. This kind of problem, in this kind of problem. So in a point over here is that if we use a normal equation, you know, we have the u plus v like I said, you'll find out that x1 is equal to u plus v, right? And u plus v is equal to cube root 3 plus 10I over 3 square root 1 over 3. Okay, and then plus cube root 3, so not cube root, just cube root. And then 3 minus 10I over 3, then square root 1 over 3. So in this case, we had these two guys. And what are you going to do? We have two tricks. And as I told you before, in this video, in that black whiteboard, I just told you, you know, I just say that we know we can create a trick. So if we have some kind of square root m plus n times square root k, this is cube root. And in this case, we can change it to cube root a plus bracket a plus square root k, and then bracket to be 3, and that's equal to a plus square root k, right? In this case, a is equal to square root n minus k over 3, and a square, a to the 3 plus 3ak is equal to m. So because satisfying these twos, I will have, you know, this is equal to this. So in this case, I had this trick. This is a trick. So when I have this trick, I can finish this problem when I had this. So I can change. I can change this thing looks like this. Actually, it's already like this, but we can just change it and more. Okay, so the first step is because we have an I. So we're gonna just put, because here are just all some real numbers, no I. So we're gonna just put I back in. Right, and plus okay. Minus 10 over 3 square root negative 3. Okay, that's cube root, right? So in this case, so we're gonna actually change it. So actually, we can just pick a negative out of here. So it's equal to negative, okay, and then square root 3 plus. So this is negative, right? And okay, and then minus cube root 3 plus 10 over 3 square root negative 1 over 3. Great. And in this case, we can change it to, we just put a negative inside here, and so of course here we have negative, and that is cube root, so it's negative 3. And we're gonna minus, what do? You just put the 2 in this, so this began to 4, and this is 5 over 3, so 5 over 3 times square root 4 over 3. Great, and then we use a plus again, right? And it's the same, but just gonna here, sorry, this is minus. Okay, so we'll plus it on. And so negative 3, and then plus 10 over 3. Sorry, here's 5. So negative 4 over 3. Great. Bracket. Okay, so now in this case, we know m is equal to negative 3, and n is equal to 5 over 3, and then k is equal to negative 4 over 3. And if you calculate it, you'll find out that a is equal to 1. And so, in this case, if you plug this in over here, it does satisfy that. These satisfy this condition. It's really one m. So, because actually, when you change this, you're just gonna find out that this actually satisfy this condition, right? Other than this case, you can just calculate it. Find it. You just need to plug it in. But this situation, so what do you need to find to satisfy? Because in this case, because of this, you already insured A. In this case, you have to plug it in and let it satisfy. That's what we're finding for. So A equal 1. So A equal to 1, then if you plug it in, you'll find out that, so this is equal to, so U equal, it's U equal 1 plus 2 square root negative 1 over 3, and V is equal to 1 minus 2 square root negative 1 over 3. So in this case, we have these two guys. So if you calculate it, so you'll have x1 is equal to negative 2. And x2 is equal to negative 1. X3 is equal to 3. So in this case, this is very different. You see, in the CE cardinal equation, right, we'll find out the first root is 3. So in this case, the first root, it is negative 2. So we have another method that we can calculate out. We can find the root, the first root was 3. Okay, it is 3. So the point, let me tell you this first, then I'll say the calculate. Okay, say the algebra, okay? So in this case, we will have what? Because we have this root, right? Okay, and in mapping to this picture, we know that means x1 in this case, because this only mapped to the CE. So in the CE, so it's this. This is 3, this is negative 2, and this is 1. So I'm kind of like, I say that in the last video. I just draw this, okay? And this is 3 and negative 2 and negative 1. So in this case, I can use this trick to find out this 3 and negative 2. This is just, I can just, it looks like a pair, but you can't just say these two guys. So it's wrong, because we could go as this and this. Okay, so let me just use the algebra to do it. So let's see. It's actually very strange because we use the same equation and we use a different trick. We can change to a different answer. We can use some higher thing. I don't know how to prove it now, but instead now we know because it actually exists. So here we have another trick. So this trick is, so first of course we have this, okay? And we're also gonna put it in. So this step is the same. Okay, so in this case, what's another trick? It is actually equal to cube root, 3 plus 20 over 3, and then square root negative 12. So we can just, here's a 2, so here we need a 1 over 4, so right, because we put in the square root. Okay, so then plus 3 minus 20 over 3 square root negative 1 over 12. Okay, so in this case, we have, we can just map to this again. So we have m is equal to 3, and n is equal to 20 over 3, and then k is equal to negative 12. Negative 1 over 12. Okay, so in this case, we also satisfy that we can find out a is equal to 3 over 2. So in this case, we can actually find a. Also, if we just plug it in, if we plug it in, we also satisfy it's equal to m. Okay, so in this case, you'll find out that x1 is equal to 3, and x2 is equal to -2, and x3 is equal to 1. So in this case, we use this trick actually find out, oh, just like this. So the point over here is that we can use the trick to find out these two kinds of roots. Okay, so this is what I'm going to add. Okay, in this video. Oh, of course, I'm going to tell you. So next video, I'm gonna talk about the Shenzhen formula. It's about, we just changed a little bit from the Cardano equation, but it's a very, it's very much I have to write, just a lot of calculating. You just opposite thinking, I'm just gonna create a formula, so I just, okay, so this is what I'm gonna talk about in the next video.